All right, let's talk about the unit circle. You know, that thing that pops up in trig class that can look, well, a little scary at first. We're going to completely demystify it today.
And yeah, I get it. You look at this for the first time, and it's just a swirl of angles, fractions, and square roots. It feels like something you're going to have to spend weeks memorizing, right? Well, here's the secret. You absolutely do not have to memorize this, ever. There's a super simple, super logical way to build this whole thing from scratch, and once you see it, you'll never forget it.
I want you to stop thinking of this as a test. Think of it as the ultimate trig cheat sheet. It's a map, and it holds the answers to so many problems. You just need to know how to read it.
So, how do we crack the code? Well, what if I told you this entire complicated-looking circle is really just built from two incredibly simple shapes you probably learned about a long time ago?
That's right. It's these two, the 30, 60, 90, and the 45, 45, 90 special right triangles. These are literally the only two building blocks you need. If you understand these, you're 90% of the way to understanding the whole unit circle.
Okay, so here's the key. We just have to make one small adjustment to these triangles. We set their hypotenuse to 1. And why 1? Well, because it's a unit circle, meaning its radius is 1. And when we do that, the side lengths become these very specific numbers. These numbers right here, that's the secret code.
Okay, so let's actually start building this thing. But we're not going to tackle the whole circle at once. Nope. We're just going to focus on this first little slice, from 0 to 90 degrees. If you can master this one section, I promise the rest is a piece of cake.
And I'm serious about this. This is the only part you really need to learn. Every other point on that big circle is just a mirror image of what we're about to map out right here, right now.
Now, get ready for a really cool and easy pattern. Let's look at just the y-coordinates as we go up the circle. At 0 degrees, it's the square root of 0 over 2. At 30, it's the square root of 1 over 2. At 45, square root of 2 over 2. You see it right. It just goes square root of 0, 1, 2, 3, 4, all over 2. So simple.
And here's the best part. What about the x-coordinates? Do you need a whole new pattern? Nope. It's the exact same pattern, just running in reverse. If you know the numbers for y, you already know the numbers for x. It's that easy.
So, let's put it all together. Here they are, the coordinates for our 5 key spots in the first quadrant. This right here is our foundation. Everything else is going to be built from this.
All right, we've baked our first slice. Now let's see how that one slice can give us the whole pie.
The logic from here on out couldn't be simpler. It's all about symmetry. The numbers, the actual fractions, are going to be the same in all 4 quadrants. The only thing we have to worry about is whether they're positive or negative.
And this is just basic stuff from when you first learned to graph. You know this. In the first quadrant, everything's positive. You go left into the second quadrant, x becomes negative. You go down into the third, they're both negative. And you swing over to the fourth, x is positive again, but y is still negative. Simple as that. Now, if you need a quick way to remember which trig functions are positive where, there's a classic saying that students have been using forever. All students take calculus.
So here's how that breaks down. A for all in the first quadrant, S for sine in the second, T for tangent in the third, and C for cosine in the fourth. It's just a handy little mnemonic to keep those signs straight in your head.
Okay, so our map is complete. Now for the really fun part, using it to find answers to trig problems in like 2 seconds. This is it, the single most important connection to make. For any angle on the unit circle, the cosine is just the x-coordinate, and the sine is just the y-coordinate. That's the whole game. Cosine is x, sine is y. Burn that into your brain.
So, let's test it out. How would we figure out the cosine of 30 degrees using our new map?
It's super simple. First, you just find 30 degrees on the circle. Second, you look at its coordinates, which we know are root 3 over 2 and 1/2. Third, you remember our big rule. Cosine is the x value. And boom, the answer is the square root of 3 over 2. Done. No calculator, nothing.
Okay, one more, just to make sure it sticks. How about the sine of 60 degrees? It's the exact same process. You find 60 degrees on your map. You look at its coordinates, 1/2 and root 3 over 2. Then you remember the other half of our rule. Sine is the y value, so our answer is the square root of 3 over 2. See? It's that fast once you know how to read the map. So if there's one thing you take away from all this, it's this. Don't memorize. Build. Understand the simple pattern in that first quadrant and then understand how to reflect it. It's a way more powerful and, frankly, a much easier way to master this for good.
You know, the unit circle looked really complicated, but it turned out to just be hiding a couple of very simple patterns. So it makes you wonder, right? What other big, intimidating ideas out there are just waiting for you to find the right key?